No, we're not done today. So goal today is pretty much identical to the goal yesterday. One difference. Every problem we're doing today is going to look identical to yesterday's homework, except for one difference. Different type of sequence, different type of pattern. So what are arithmetic sequences again? Got to be addition, right? Geometric, no, because with arithmetic, can you have, you can obviously have something like 10, 14, 18, 22, yes? Because you're adding 4. Can you have a sequence that goes 30, 27, 24, 21, where it's going down? Yeah. What are we adding? You're adding a -3, right? So yeah, technically arithmetic is just addition, but you can go up or down. You can still have your D value can be positive or your D value can be negative, right? So you still can go up or down. So it's not addition or subtraction. So what do you think geometric sequences are? Multiplication. So now we're dealing with patterns like 3, 6, 12. What will be the next term? 24, 48, and so on and so on. Okay? So yes, geometric sequences, we are dealing with multiplication. What type of pattern is this? Think mathematical equations. These are exponential, which means if we're dealing with exponential patterns, don't be surprised if you start dealing with some really big numbers fairly quickly, because geometric sequences, remember, your geometric functions are the fastest growing functions there is. So yeah, don't be surprised if once in a while you start dealing with some big numbers. Like in this pattern, if I asked you to find a sub 15, that's going to be a fairly large number, right? So we got to come up with our equations. So right now, the only formula we have is for arithmetic sequences. Our a sub n equation is a sub 1 plus d n minus 1. What we need right now is the same kind of thing for geometric. Okay? So, with geometric, we can do things recursively again or explicit. Now, we don't have a common difference. Instead of a common difference with geometric, what do we have? Close, really, really close. It's called a common ratio. Meaning, I can divide, right? If I take any term and divide it by the term before it, I will get the same ratio all the time. If I divide 48 by 24, I'm going to get 2. If I go 24 divided by 12, I'll get 2, right? 12 divided by 6, I'll get 2. So in this case, my common ratio is 2. So we don't have a common difference, but we have a common ratio. So that's one difference. Now, with recursive, with that pattern of 3, 6, 12, 24, if my ratio is 2, how would I define that recursively? How would I find the next term? I would take I could find any term by taking the term before it and doing what? Multiplying by 2 or r, yes? R, or in this case 2. Make sense? So let's talk explicitly. So recursively is pretty easy. With recursive, if the pattern is 3, 6, 12, 24, this is my a sub 1, right? How did I get the 6? I took the 3 and I did what? Multiplied by 2. How did I get the 12? I took the 3 times the 2 and I did what? I times that by 2. And then I took the 3 times 2 times 2 and I times that by 2. So now instead of repeated addition, now we're doing repeated multiplication. What's our shortcut to do repeated multiplication? Exponents. So yes, these are going to have exponents in them. So how would I find the next term? How would I find the 48? You're just ahead of me. Yeah, it would be, the 48 would be how many 2's would I have to multiply together? It'd be 4 of them, right? Now, yes, this is my a sub 1, this is a sub 2, this is a sub 3, a sub 4, and this is a sub 5. So the fifth term had 4 2's. So what's my explicit formula going to be? This is my a sub 1. That's my r. And how many r's am I going to need? N minus 1. So my explicit formula is, or my general term, is a sub n will equal my a sub 1 times the r to the n minus 1. So I can find any term I want fairly easily. If I wanted to find, in this pattern, a sub 15, like I said, how could I find that a sub 15 fairly quickly? I need my a sub 1, which is 3, my r, which is 2, to the what power? 14. And then I just grab a calculator and figure out what 2 to the 14th power is, which is a fairly large number, times that by 3, and I have my answer. Geometric sequences work exactly like arithmetic sequences, except we have to use the different geometric sequence or explicit formula. Now, remember how in the homework, whenever I ask for a general term, you get to here with arithmetic, and then you got to distribute and just simplify a little bit. With this general term that I just wrote, I never actually wrote it. So this one would be a sub n equals 3 times 2 to the n minus 1, right? Is there any simplification there? There really isn't any. We usually put parentheses around the 2. That just makes it a little clearer to see instead of using the dot or the times. But that's really it. There isn't going to be any real simplification. The only way you would ever simplify something would be a pattern like this. What's the general term here? What's my a sub 1? 3. What's my r value? 3. Now, when those two things are the same, you can simplify that a little bit. What's the exponent here? When you multiply two numbers with the same base with exponents, what do you do with the exponents? You add them. What is 1 plus n minus 1? It'd be just n. This would simplify to just 3 to the n power. When's the only time you would ever be able to do that, though? When the a sub 1 and the r are basically the same number. That's the only time you'll be able to do that. Other than that, you'll never simplify a single one of these. So let's try some. Everybody look at page 481. You're going to notice, Sorry, 381. I don't know why I did that. 381. 381. You're going to notice that the homework is going to look almost identical to last night's homework, which you guys did so well with. The only difference is it's a different type of number, or different type of pattern. So number 1, we're doing practice exercises. They give you the a sub 1 is 3.5. They give you the r is 3. How are you going to find the first 4 terms? First term is 3. And then what do you do? Oh, 3.5. How do you find the next term? Times it by 3. So, all right, we'll grab a calculator and do it. So the first term is 3.5. 3.5 times 3 is 10.5. Times that by 3, 31.5. 94.5, however many you need, right? Easy? Okay. How about number 7? Now, number 7, you got to be careful. What's the r value? -3. Notice what happens when you have a negative r value. What's going to happen here? It's going to go positive to negative, positive to negative. That's actually really, really important to pay attention to because there's a couple things that are going to cause us difficulty with these. So, number 7, we got to write our general term. What is my general term? What's my a sub 1? 3. What's my r value? Is it -3 or -2? Oh, it's -3. Can I simplify this one? Are these two numbers the same number? No, 3 and -3 are not the same number, so no, you're done. That's it. Easy enough? But yeah, pay attention to when the r value is negative, you get a different type of pattern, okay? Because it's going to go positive to negative, positive to negative. And that's really important to talk about when we get to a problem. I want to look at number 20. So let's look at number 20. It says insert 5 geometric means between 32 and 1/2, right? How do we do these? This is a sub 1, which means 2, 3, 4, 5, 6, a sub 7. Now we're going to write a geometric equation for this one. 1/2 would have to equal my a sub 1 times my r to what power? 6th power. How do I solve this? Divide by 32, right? So this would be 1/64. How do you get rid of the 6th power? You raise to the 6th root. If you want to type in your calculator, just raise it to the 1/6 power, right? Now, there's something very, very important you have to remember here. I'm taking a 6th root. What does that mean? What is the 6th root of 1/64? I'll give you a sec. What's the 6th root of 1? What? 1. What number multiplied by itself 6 times gives you 64? 2? So r is 1/2? Does everybody agree? You'd be wrong. You're doing a 6th root, not a 5th root. Anytime you take an even root, what do you have to remember? Plus and minus. There's actually 2 different patterns that work here. one pattern to get from 32 to a half is, yes, you multiply by a half. You can go 32, 16, 8, 4, 2, 1, a half. That works. When r is positive a half, that's the pattern. What would the pattern be when r is negative a half? It would go positive, negative 16, positive 8, negative 4, positive 2, negative 1, positive a half. When is the only time you're ever going to have to remember the plus or minus? Even root. If you take an odd root, you don't have to worry about it, because the alternation of the positive, negative doesn't always work. It depends on how many numbers we're inserting here. Throughout this assignment, if you ever take an even root, you have to remember plus or minus, because there might be two solutions to the problem. Okay? Because there's two different patterns that would work for that situation. You could run into those there. You could run into them on the like 29 through 34 is where you got to set up a system of equations. I want to try one of those. What time we get out of here? Yeah. Let's try number 30. So they give us, I'm going to do it backwards. A sub 10 is negative 189, and they give us A sub 8 is negative 21. For all of these problems, what do we got to do? Set up a system of equations, right? What would negative 189 have to equal? A sub 1, which I don't know, times r, which I don't know, raised to what power? The 9th power, right? And negative 21 would equal a sub 1 times r to the 7th power. Can I subtract these numbers? No. But what I can do is I can divide those. Because when I divide like 2r to the 6th divided by 2r to the 4th, what happens with my 2's? They cancel, so my a sub 1's are going to cancel. And what do I do with my exponents? You just subtract your exponents. So when I divide these, my a sub 1's cancel. I end up with r to the 2nd power. Now I just got to divide that. What's 189 divided by 21? 9? And then how do you get rid of the 2nd power? Square root. What's the square root of 9? Plus and minus 3. There's two different answers to this. There's an answer when r is 3. There's an a sub 1 that goes with that. And then there might be a different a sub 1 when r is negative 3. And you got to just plug them in and solve for both. Okay? It'll be similar, and sometimes they'll be the same a sub 1s, but we do have two different patterns here at play. Does that make sense? If you ever take an even root, you have to remember plus or minus. All right.